name is John Berryman. Just to give you a little quick introduction, I started out with aerospace engineering, and that was a lot of fun. Good math, good software, but I always thought that those were the coolest bits, because you can do anything with math and software, and satellites is cool, but it's just one thing. So I soon got into other things, and it was search technology at first. I worked with Open Source Connections, who's still, I think, fairly prominent here in town. Ended up getting the opportunity to write a book. Said, this is crazy, I shall never do this again. I ended up, after that, working for Eventbrite. I pictured here, worked for GitHub, still very much in the search mode, but got a really cool opportunity, right place, right time, and I was one of the early production engineers for GitHub Copilot. So it's kind of a neat thing to see. And of course, since I said I'd never do it again, I did write another book about my learnings from that time. And as of almost a year ago, not quite, I started an independent consultancy called Arcturus Labs. Please visit at www.arcturuslabs.com.
Is that Arcturus?
Arcturus, yep. It's a navigational star. Guardian of the Bear. Now the question that I bring to you guys, I did a silly thing, and I want to see if you guys want me to just like dig into the silly thing I did. I put together a 3-day, 6-hour course on prompt engineering, Retrieval-Augmented Generation, AI, agency, everything. And I came to Charlottesville, and I'm in Nashville now. And I had the opportunity to present the 6-hour course as a 3-hour course, so I had to compress it quite a bit. Went well. I also had the opportunity to present the 3-hour course as a 90-minute course. Went pretty well. I think tonight I bet you can tolerate me for 45 minutes. So either we could try this compression one step further. Sorry, Mike, you can see everything you've already seen at double speed. Or I can go back to what I officially was going to present, which is prompt engineering, which is kind of a history lesson through all the interesting prompt engineering stuff. So think about, we're going to do a raise your hands type thing. You can vote twice. Who wants to see prompt engineering specifically, that specific topic? Boring, okay. You might. Okay, who wants to see the other thing? Okay, I was afraid that no one would raise their hand either time. Okay, all right, so this is the 90-minute course. We're going to do it. And how much time shall we give me?
Oh, gosh.
Well, like what time?
I think we give you about 45.
Okay, so what time is that to wrap it up? Like 20 after? 20?
Sounds good.
Somewhere
We'll
there.
cut you off if we have to.
Yeah, just clown on the rubber mallet.
We'll start leaving when
That's how my talks usually end, when people start walking out. All right, then let's dig in. To some degree or another, we're going to cover all these topics. Some are going to be kind of quickly running through them. Prompt engineering, RAG, agentic AI, evaluation, which everyone's having trouble with, but it's important, fine-tuning, and there's no way on earth we're going to get the future LLMs. Don't worry, it's just fluff content anyways. In the beginning, there was the completion prompt, and we had many ways of talking to these language models. Basically, all they could do, they couldn't chat, they couldn't use tools, all they could do was look at the top half of the document and make a guess at what the follow-on content is. And that ended up being a very rudimentary tool for pulling content out of these things. So we came up with a lot of different approaches to get work out of these strange alien technology that we created. The first thing is few shots prompt engineering. A shot here means like just one example. So if you're trying to convey a pattern to the model, you give it several examples, and if these things are really good at seeing patterns, if it finds a pattern, it'll continue it. And you just point that pattern in the direction that you need work to be done in. So let's do a quick example. You find a document on the ground, it's ripped in half right underneath this line. It says, please translate this to Spanish. How are you doing today? What is it likely to follow up with? You would think you would translate it. But the models, these original models, find a pattern. How are you doing today? Well, I've seen lists of questions online before. So it's going to say, where's the bathroom? Can I have some water? What time is it? It's going to follow some pattern. It's not necessarily the pattern that we as humans would anticipate. So this is a big problem in the earlier models, but we figured out that you could just say, you could give it a more consistent pattern and it would figure out what to do. So you say, angle bracket going to the right. How are you doing today? Angle bracket to the left. ¿Cómo estás hoy? Angle bracket, English. Angle bracket, Spanish. Angle bracket, English. Angle bracket. And we give it all the hints so that the most obvious pattern that it can follow is not just making more questions. That would be out of place in this case. The most obvious thing it can do is actually translate stuff. Good. We're getting work out of these things. Fortunately, we also started realizing, and this is kind of a theme and maybe one of the reasons I didn't quite want to do the prompt engineering talk, a lot of the cool tricks that we figured out with prompt engineering have been such good ideas that we've slowly baked them into the model. And so this slide is kind of the first example of that. The original models just took a document and completed it, but we realized that it was kind of unwieldy to work with. So soon we trained the models to be instruct models instead of just completion models. They assume that any document, any text that you stick into it is the start of instruction, and so it primes the model to always be looking for a way to answer something. This meant that it was a lot easier to get the behavior that you kind of would naturally anticipate out of models. Please, not the red text, please translate this to Spanish, how are you doing today? Since it assumes everything is a request to be answered, then it is likely to produce the requisite ¿cómo estás? Models don't have an internal monologue. If I was to ask you a complicated question, then without even helping it, you have this simulation in your head to help you resolve it. And it's a rich experience. It's words, it's pictures. The models, they really think one token at a time. And every token takes the exact same computation, and that's the only way they think is by making more tokens. So we make use of this as well. Quick question to everybody. It takes an hour for one shirt to dry in the clothesline. How long does it take 3 shirts to dry? Answer, what? So you guys are all smarter than the original models. Because the original models would often find a statistically plausible thing to complete it with and be like, my quick answer that seems like it's going to fit is 3. There's a pattern here. 1, 1, 3, 3. So what we found out that you should do is tell the models to think about it. And effectively, you can prime the model to think about it by setting up a pattern. Like you can say, it takes an hour for one to blah, 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 and if you start the completion on behalf of the model, basically we're putting words into the assistant's mouth in this respect. And you say, let's think step by step, then a really unusual following next character to that is going to be 3. Let's think step by step 3. No, instead that kind of primes the model to be like, oh, okay, well I've got to actually do this. It actually does a good job about thinking through the pattern and coming up with a more rigorously conditioned answer. All right, at this point, models are getting more powerful. We're starting to realize some of the problems that are inherent in these models, like hallucination, the inability to look outside of their training to answer questions. And so we start to give them tools and tell them how to think. In this paper, very influential paper, that basically arrived when I did this. Is one of the early papers that I ended up reading. Is how many rooms? We pose questions like this: how many rooms are in the hotel that is home to the Cirque du Soleil show of mystery? And the answer that it says is your reaction 2,664, which is wrong. It might have been correct at one point, but how can a model know if the hotel has updated its room layout, if it's doing something new? So in this React paper, we gave the model the idea of functions that it can call upon. And we told it, you can search Wikipedia. Within a page, you can look up some context, and once you have an answer, you can say this is finished. It's a loop where you're always trying to think about what is said above, choose an action, observe the output, and eventually come up with an answer. led to much better results. If we ask the same question, then what it immediately chooses to do is search for Cirque du Soleil, show mystery. The output in this microscopic example says, I couldn't find the Cirque du Soleil, so the model knows, so it can read this and say, okay, well, here's some other things I can search for. It searches for a different version of it, that's fine. Once it reads that request, that response directly, we're piping in Wikipedia fragments now into the prompt. It says, oh, okay, well, I know enough to see that it's Treasure Island. It searches for Treasure Island, and on that page, it has the number of rooms there. So, React was a really important thing for a lot of reasons, but it's it's not going to help. It reduced hallucinations by allowing these models to reach out into the real world and actually, look at information as it is rather than as it was in your training. Today, almost all large language models have been fine-tuned to use tools. This was the start. Every time that a large language model is looking to the outside world, especially searching stuff and pulling back documentation, that's RAG. That's Retrieval-Augmented Generation. That's this paper. Every time you have an assistant that's in this loop of I'm going to think and I'm going to choose functions and I'm going to act on them and just follow this loop, that's a structure, that's the simple but the good structure for an agent. This is also this paper. So a super important paper, pretty simple paper, but it kind of spawned a lot of things that happen in the future. There's a lot of other cool ideas. Tree of Thoughts is another one where you basically have to model, figure out different approaches, plan its approach, and then when it finds itself in a corner, you can tell it to back up and restart again. That led to things like these reasoning models that we have recently. In these slides, which I'm going to skip because this is my 90-minute presentation, I showed how you collect a lot of this information and make prompts. This is basically how we did GitHub Copilot. We collected whatever file you're working in. We collected the most useful information from neighboring tabs that you have open. So like you can see what you're typing, we can see like the closest matching text in all the neighboring files. Dump that into a fake document. These things are just completion engines at the time. And that's how we made completions. That's all up until I left. That's the whole secret sauce right there. Copilot was not doing that much. If you're prompt engineering, a really good mental model is just to pretend that LLMs are your dumb mechanical friend that happens to have read the internet and memorized it. This means that they are going to do a lot better if you give them something that they're familiar with. Give them patterns that they've seen in training, like HTML, obviously, Markdown. If you're doing some sort of legal document or finance type stuff, use like SEC, the pattern SEC report, something that you don't have to teach it a new thing. Just let it use its old patterns. Models are not psychic, so if you're asking something, basically when you give the model a prompt, it's a piece of paper. It says like solve this problem for me. If you would have to be psychic to solve it, they're not going to be any better. So kind of empathize with the model in that respect. Models have limited attention. If you dump in everything just in case it might be useful, then sometimes it might work. Models are getting smarter, but a lot of times it'll distract the model, just like we would be distracted with 500 pages of one page each relevant stuff. If you, as a human, look at the model at the prompt and you can't make sense of it, the LLM, being your simple-minded mechanical friend, is going to be helpless. And finally, just like us, give the models some room to think. Give them a chance to talk about the problem before they actually commit to a final answer, and they're going to do a lot better at getting a better answer. Retrieval-Augmented Generation. Like I said, LLMs are not psychic, so they can't get private information behind corporate walls. They can't get at recent news. For instance, the training date was before the presidential election. They really don't know who the president is at this point, unless it's being added from the outside somehow. Real-time content is another thing, like prices of airlines and stuff like that. So what RAG does is it gives the model a chance to make a request, reach out to the world and get the relevant information, up-to-date stuff. But a key point, everyone talks about RAG as if it's a thing, but it's really two things. And if you keep them separate in your mind and in your design, then you can debug problems that arise. It's retrieval, search engine stuff that has been around since forever, and it's generation, new LLM stuff. But think about those two things separately, and if something goes wrong, it's not one black box, it's like it's things that you can kind of see through and solve the problems. There's two main types of search, lexical and semantic. I'm going to blow through this, but semantic search has become kind of the de facto for RAG. And part of my thesis here is it's a little bit unfortunate. Semantic is great at matching on meaning, because basically you cast the content, the text of your document, whatever you're searching on, into a vector that represents the meaning of the vector, so of the document. So when you search for something, if you search for a gorilla costume and the document has monkey suit in it, it should probably be a match. But if you're just doing like word matches, it's not going to notice it. Semantic search will notice it. That's cool. Semantic search involves taking the document, giving it to an engine that embeds it as a vector. The vectors is just a long list of numbers, but the vectors have a quality, whereas nearby meanings, gorilla suit, monkey costume, are going to have vectors that are kind of pointing in a similar direction. And sundress is going to be like over here, something that's very different. That's the only property that you have to remember for these embedding vectors. Skip, pass. The vectors get stored in a vector database, but since the vector database since it's been a useful thing, all the latest, the greatest hits, Postgres, Mongo, Elasticsearch, decided, well, this is a cool idea, we'll just do it too. And a lot of the times they do a good job. So these days, I think I might recommend that you just go for something that you're already familiar with that has vectors also baked in. Lexical retrieval is kind of what I cut my teeth on. It's what I'm still more comfortable with. I believe it's underutilized for RAG. Unlike semantic search, it is doing matches on words instead of matches on ideas, which means it's still matching on meaning, but you do miss some things. Like the monkey suit thing, it's not going to do that very well. But where semantic search can match on meanings, semantic search is not going to be able to do the times where you do want to do very specific lookups, like product ID or a movie that has this phrase in it, something like that. Semantic search, no way. So lexical search has some neat capabilities about actually being able to do the exact word matches, and it also gives you some cool superpowers. So this is how lexical search works. Just let your eyes glaze over for that. But some things that it can do, this is what we were talking about, Mike, is unlike semantic search, which is going to say, here's your query, let's find the 15 nearest documents. With lexical search, you can return to the 15 nearest documents, but you also have really easy access to all the documents that would have been a match. They're not on the screen, but you still have them. And you can do really quick runtime aggregations. And you can, the side box on Amazon, we get counts for like the different sizes for this t-shirt and the different colors and stuff like that. You can do aggregations on steroids with Elasticsearch, with some loose thing. And this is a cool thing to present back to the model. You can say, not only here are the search results, but here is all of the information around the search results. You have this distribution of Airbnb houses, you have prices, you have these different sizes for the shoes you're looking at, stuff like that. It also has the ability to return snippets. So you say, my document is 30 pages long, but it's clumsy to toss all of that into the the prompt. So why not just, find, the 500 words of text that is the most relevant within these documents. Find several examples of that and dump that in the prompt too. The big catch with semantic and lexical is they just don't play well together. The good stuff from semantic is exactly the bad stuff from lexical. You can search really good with meaning, but lexical does not match well with meaning. But semantic is not good at searching for jargon terms that weren't in the original embedding vector training. It can't search for product, like SKUs. It can't search for phrases, whereas lexical is good at that. And unfortunately, the two data structures, the two predominant data structures that support semantic or lexical, it's like they're oil and water. You just can't. There's not an in-between data structure. So there are some things that we're doing to help overcome this, but I think we're still waiting for a magic data structure that does both of these cool things equally well. Let's talk, if there's a Q&A afterwards, that's what we'll do right now. This is a good small demo, and I just want to do the other demos. It's probably the best demo to do. What is the resolution of this screen?
Yeah, pretty low res.
I can fit 2 characters on the screen. Wow, okay, so I'm going to clear this. I'm going to cd da. Rag, I'm going to Python. Okay, so it's running, and I'll show you if I can. Here is a really simple example of RAG. It's faked out. RAG is 2 parts. What's the first part?
Search.
What's the second part?
Generation.
Yep, generation LLMs. So here is our search index. I've indexed movie titles, and guess what? I just listed them there. So if the user says that they want to search movies about or title, if they want to search movies about whatever, then I'm going to return these movies right here. If they want to search movies based on the title, I'm going to return these movies right here. It's a really dumb thing. I mean, it's not doing search, but that's the part that's faked out. Because this is focusing on the implementation of the prompt side, the actual the LLM implementation. When you're building an agent, when you're building RAG, you tell the model about the search function that it can use. This is basically, you're saying this is how you reach out into the world. Almost all to my knowledge, everyone that uses functions in their LLMs, they use JSON schema for describing the things. In this JSON schema, we say that we have a function called search movies. We give it a description about what it does. Really important to be descriptive and precise here, have intuitive names, because this information goes into the prompt, and the LLM actually sees this, and that's how it knows which function to choose if you have multiple functions. Just like you'd expect from above, we tell the model that this function has an about field, which if you specify it, then you describe what the movie is about. That's going to be doing our semantic search. If you have if the user says, I want to find a movie with this particular phrase or something, we're going to do a title match. We're going to look for something that matches in the title. And here is the actual implementation of our really simple one request only agent. It takes the user message, which is just text about my preference. It's not like a search. I'm just saying what I want to watch tonight. It takes the user message and appends it into a list of messages. Starts with the system message, which is basically the instructions to the model. You're a good assistant that can do movie lookups. And here's the user message, whatever I say. Toss this request into GPT-4o mini. We got to tell the large language model, got to tell the LLM that it has access to these tools right here, just one tool in this case. And then we wait for it to come back with a response. The response might just be text and give that back to the user. But since we've told it you got tools that you have access to, then we need to double check, because the model might actually say, oh, okay, I'm going to use a tool for this request. For your sake, I'll print it out on the screen. But the tools, we need to, for each tool call that it makes, we need to say, okay, well, tell me the name of the function that you're going to call. There's only one option in this case. Tell me the arguments that go into the function. I'm going to actually run the function right here. So this is the model asking for something to happen in the real world. In the real world, we make a movie search, and we take that information that comes out of that response, shove it back into a message so that the model can see the user message, it can see its own search, it can see the search results, and now it has all the information that it needs to make one more response to the user, and we take it and we print it out to the screen. So I just ran this. Let's go ahead and see what it looks like. If the user says, do you have any good gunslinger movies? So it's going to do a search, and it correctly uses the about parameter as opposed to the title parameter, and looks up gunslinger. Good. The tool response comes back with, presumably this would actually do some sort of search, but it comes back with relevant titles. The model now makes another request and sees all this information at once, and that gives it the ability to make a useful response. Here's some gunslinger movies. It just organizes the content that it just received from the real world. If, on the other hand, you say, all right, I'm looking for a movie that has the best in the title, then appropriately the model calls the right function, there's only one function in this case, uses the other parameter. So we've described the function well enough so that it picks the correct parameter, and fake response, but it gets the results back, dumps that in there, and it provides a good summary of what it's just learned. If you say something, tell me a joke about a chicken, then appropriately it does not make a tool request because it has nothing to do with movies. That's important too. And it's also got a really clever sense of humor. Why did chickens join the band? Because it had the drumsticks. But check. And finally, one cool thing that you can do when you're building an agent like that is if the tool has an error mode that is recoverable, then instead of raising an error in there at the application layer, you print out an error so that the model can see it and have a chance to recover. Give me a random movie, unqualified by either title or description. It makes a request with nothing. And if we went back to code, I actually have it return a textual error instead of raising an error. And so the assistant says appropriately, I can't provide a random movie with that criteria. You got your stuff. So the model trained it how to recover from stuff, which is kind of a neat little feature here. Poof, agentic AI. We're done with red. Two types of agentic AI, conversational and workflow. The easiest form of a conversational agent is just a loop with a user message, and you ask the model to respond. But they're boring because the model can't do anything useful besides providing therapy sessions. So give the model some tools, just like we showed, where it can reach out into the real world. Defining this agent is just as easy as the example I showed you. You have a system message that defines the role of the agent, the behavior that it's supposed to have with your customers, or the users, the environment that it works within, and maybe some examples. If it's kind of a unique space, you can show it some examples about how it works. The agent has tools. OpenAI recommends less than 20, but depending on the complexity of the tools, you need to do a lot of experimentation to figure out where that is. They should have good descriptions, clear, and not necessarily concise, just more so like explanatory. And then you have the loop. So you have instructions, tools, and the loop, and that's all there is to an agent. The loop is just like the example that we just showed is basically this right here. There is an outer loop that actually makes this a conversational agent, where as soon as the assistant comes back, the user has the option to say some more things to it. And you can go around and around and around this loop, and the assistant will take actions with tools into the real world on your behalf. Sorry, no demo, no time for that. And this is also something that there's just no time to explain this too much. I really dig UI UX, and I think working with this alien conversational technology that we've created is going to be challenging for user experience. It's a very different thing. So one thing I think is useful is having your agent, your assistant, explain to the user what it's looking at. Because that's what we do. When I'm trying to work with you guys, if we're pair programming something, I want to make sure my mental model is shared with you. And how can I know that if like we're pair programming and you're like, not even attending to it? So show what the model sees and the user will have a better understanding. More than that, show what the model thinks about. If you say, solve this problem, it's so much better that rather than just like receiving here's the solution, it's so much better to see the model propose an idea, act on the idea, follow up with an explanation. And remember I said models need room to think. All this extra chatter in here actually implies a better solution because it has a chance to actually pre-cogitate whatever the answer is going to be. I hate skipping that one. We're pushing the limits. Workflow agency is the other main flavor, I'll say, of agency. One, you got this conversational loop. In this conversation, the human is in the loop trying to guide the model to keep on track. With workflow agency, we do something different. We have basically a set of steps that is a priori decided by a developer to keep the model on track. In both cases, it's a human that keeps the models on track. Just the space of possibilities that can be explored by hard problems is too big to not have a user on track. This is my introduction to agency. And the microscopic text here, I'll just kind of summarize it for you. This is early 2023 Twitter thread. GPT-4 was a new thing. And Spencer Scott, who I don't know, was flabbergasted and said, "We are all effed." There I said it. I just saw the most impressive display of AI I've ever seen in my life. Basically, what his buddy Umar had done was scrape the top Shopify pages, run through the content of their webpage, spam them all with like new product ideas, and he got replies, a lot of replies. And it was pretty good too. I mean, this is 2023, and I won't read it all, but like here's one of the letters that went up. Yo, what's your name? It's really fun, upbeat. I'm absolutely loving whatever socks. Your mission to support childhood education is awesome, so it's kind of ingratiating itself with the person. So I've got this amazeballs idea for Shopify app that's going to boost your sock game even more. Picture this: success stories. That's like that's what when the light bulb went on. It was like, this is a new world we've went into. And basically, this is not a complicated thing to build. A workflow is a set of steps. You emit a bunch of Shopify HTML. You extract relevant details. You generate a plugin concept. You compose a snazzy, ingratiating email. And then you spam your potential clients. But the idea is pretty simple. Create a bunch of, if you got a big idea, a big bunch of work to get done, break it up into small tasks. Make sure each task is pluggable together and workable in isolation. That way, your problem is not one big hairy problem. Your problem is just a few set of simple steps. You can make sure, if anything breaks, very easy to isolate it and figure out what's wrong, fix that, and you can iterate and improve the workflow. Workflows can be a chain. That's where the word lang chain came from. They can be a directed acyclic graph. They can be Cycles, that comes with more complexity, so be careful if you actually adopt a cycle. But this is the anti-pattern. Don't do that. If your graph looks like that, you've gone too far. Start slow and build up. The fun demo time that we get to miss now is I actually built the app. I did it for the book. I wish I'd actually sent out some of these emails just to see if I got response, but I never did it. Should have done it. Which framework do you choose? I don't know. I really don't. I've looked at some of these. I haven't looked at some of them that I probably should have by now. A lot of people that I talk to say something that resonates with me, that the API for large language models is pretty simple. It is actually becoming fairly standardized. Just dig in, get your hands dirty with like the actual thing you're working with without using a framework to cover it all up. I hope that I'll have something different to say in the months ahead, but right now everything about this technology is changing so quickly that it's hard to say what's actually going to exist. And I've asked him about his predictions later. Evaluations in 8 minutes left. Suck for everybody. Next conversation. Here is my metaphor for evals. Basically, you have a prompt template that takes in the context, whatever the user is, information about the user, their desires, and it has an output. And the metaphor here is strings. But if you start just vibe testing, you put in something different, and out comes something that's shaped very different. So this is how you realize, it's time to get a human expert. The human is not an engineer. For goodness sakes, put someone in charge of it that knows whatever the domain is. If you're selling, high-heeled shoes, do not have me trying to figure out what's wrong with the criteria here. Humans do not scale very well. That's why we need to use automated testing to capture the important criteria and take it a little bit easy on the human. We can monitor traffic with automated testing. We can't monitor traffic nearly as well with just one person sitting there watching stuff. When you build an automated test, they usually have kind of a similar shape. Let's say that we're building we're trying to test this prompt, or we're finding movie sentiment. In order to make a test, we keep track of a bunch of examples. So it was like watching paint dry, but somehow less exciting. Different examples of movie reviews. We have the prompt template that we're trying to test, and when we push each one of these reviews through, we get some responses. The idea of an automated test is to be able to look at these responses and say good or bad. And if you can say good or bad, then you can aggregate those and have a rolled up metric that you can watch change over time. So in this really simple 3 instance case, we have a 33% pass rate for our movie sentiment analysis. Really, you'd want to do something that was like 40 or 50 items that you could pass through. Run them all through, and then you can plot this number right here on the chart and see if you are improving over time, if you have a product change, or if you have a prompt change. You can see which direction you're going. If your user clientele changes because something in the news, you can also have this running in the background, and you can see if some behavioral change has changed the way how effective the prompt is. There are 2 types of evaluations. Algorithmic's the easy way. Basically, anytime you look at a prompt and a completion, and you can just have an algorithm say whether or not it's done the right thing, that's the happy spot to be in. If you're doing content extraction, I've got a webpage for hotels, and I want something that extracts the title, the name of the hotel, and the address. Well, it's fairly easy to write an algorithm to look at a bunch of input hotel pages, a bunch of outputs, and see if it actually just string match. Did it actually capture the name of the hotel and stuff like that? There's several things that you can do like that. But where it gets tricky is where how well your model is doing depends on a very subjective output, subjective rationale that a human needs to look at. What is the quality response? Is the model like hallucinating facts, or is it actually telling a story that is based on the context we're giving it? Gut checks like, is the new completion better than the canonical good enough completion? Stuff like that. These type things, you can't write a Python script to say good or bad. You actually have to use an LLM to evaluate the LLM. So we're going meta. Yeah, this is challenging, and this is actually one of the longer bits in here. I tell how to create an LLM as judge setup. It's not easy. I think is a whole ecosystem. We're still kind of wrapping our minds around how to do this efficiently. But the idea right now is basically you have an LLM in charge of these subjective calls, and you try to. You're like doing one level meta, evaluation, because you got to make the LLM's judge as good almost as a human at making these judgments as your human expert.
Real quick, is that in your book?
Not like this. This
Okay.
is one of the things that I modified. We told in the book how we did evaluations for Copilot, and there's some cool stories in there. But I kind of like what I've learned after writing
Okay,
the
cool.
book.
Right.
Oh, and maybe I'll give a shout out actually. My inspiration for this, I'm stealing a lot of ideas from this guy. I need to sit out the slides here. But Hamel Hussein, yeah, I at least got his name in here, came up with a lot of patterns. His specialty within LLM consulting is evaluations and making these models do what you want. Really smart guy, and he's got some practical ways of tackling these really challenging problems. Fine tuning. And actually, we might wrap it up with this. Fine tuning. Heck, we could wrap it up with this slide right here. When to use fine tuning? Rarely. Thank you, guys. Good. Yeah. Fine tuning is really cool because you can take this model that used to just be a completion model, and you can make it act like a chat assistant. You can make it call tools. You can make it have reasoning capabilities. That's things that these large companies have already done with the raw models. But we have that power in our hands too. We can do cool things to change the way a model behaves and craft it to exactly what we need. But it's at a very significant cost. Whenever you're fine-tuning a model, you've got to realize that it's a lot of work. You've got to do it every time you change base models. You've got to do the fine-tuning again. Just because you're trying to do it doesn't mean it's going to work. I don't have any time to say this example, but it's a funny example, so I say it. One of my consulting friends was training a model to do frequently asked question extraction. Give a bunch of documentation, extract frequently FAQs. And for whatever reason, he's like, the base model is not good enough for the smaller model. We'll fine tune it and it'll be better at it. He was right. The model did a really good job about reading a document, pulling out all the questions and answers. Until the FAQ got longer than, somewhere in there, then all of the frequently asked questions would revolve around gremlins. It's called catastrophic forgetting. It does happen sometimes, and when it happens, I don't know what you do. Start over. That's what you do. When to use fine-tuning? There's some places where you can change the output structure. You can have models that are smaller and cheaper to do the work of the bigger models. These are valid, cool things. Also, you can wait 2 months and probably get it these days. So several slides here talk about how to actually perform the fine-tuning. I've got an example that was one of the projects that I was working on. But the idea is not terribly hard. Basically, you take a bunch of messages that are broken, manually, potentially, rewrite them to exhibit the behavior that you want. Or you can use another model to kind of help you rewrite into a better behavior. and then ship that off to OpenAI or wherever your model is. There's a lot of different places. They just, you give it the training files, say do the job, and you look at your clock for five minutes to an hour, something like that. And then you can use it. So instead of saying GPT-4o, you can use the special name that you register your fine-tuned model with. So this is the fluff content, but I will read this slide because it just really kind of gives you the idea of the exponential times we live in. In 2019, back before anyone noticed, the models were capable of filling in for humans for 2 seconds worth of unguided work. They were effectively doing word completion. 2022, the models could do about 30 seconds of work unguided by a human. They were an interesting toy problem. 2023, that's when things, it started getting kind of crazy. 8 minutes of work by itself. 2024, 30 minutes of work unguided. 2025, 1 hour task. And if you extrapolate, this, I don't know if you have to read the paper to see if you agree with all their assumptions. But this is a fairly straight line. If we extrapolate this exponential, then by 2028, agents can do 1 day of work completely unguided by us. By 2030, they can do 8 months of work. That's crazy. It's all fluffy future numbers. It has no real meaning. But haven't you seen kind of this weird exponential curve that we've been riding for 3 years? So a lot of new things happening with models. The models are really going to benefit the world in some areas, and are really going to be a source of risk for other areas. So it's up to us to figure out how to wield this strange new tool very carefully and make the world better. So there's my favorite slide. I don't know, how'd I do? 40 minutes? Serious question. I was talking really fast. Was that okay? Were you able to pick up stuff? Good?
Nah, I think good. Yeah.
Okay, well that's it. I guess I could take a little time for like a question or two or something.
Yeah, and after this next section, we'll have a just kind of open space that we can
So you guys
talk about whatever.
Well, any questions for now while John is still doesn't go fall over yet? Yeah. Let's do them while they're fresh from the presentation.
Okay. You ever heard of using a small model like Bellwether, sort of an idea to test prompts that to see if the results are going to be useful on a larger model? Like, is there a mapping there at all?
Oh, I had someone earlier that was telling me that's how they were doing things, but it was puzzling for me. Like, if I can build it with a smaller model, then by golly, I should be able to build it with a bigger model. I mean, that logic follows. But usually these days, I would just say, try it with the largest model possible, and then wait 2 months for the price to, cut in half or something like that.
I think the idea is they're testing maybe changing prompts over time and trying to make sure that the results are good. The question is whether or not that would actually be a signal or not, right? Like, is that an approach that would work? I guess just try it, right?
Yeah, always. My recommendation is always get your hands dirty. I've not heard of that. It is kind of an interesting idea. If it keeps working for the smaller models, then surely when I make an upgrade or change over, it's not going to be too disruptive because I'm using a smarter model. But I'd be interested if you could dig up some more information on that. It might be something new for me to learn.
I'm learning topic modeling using Berryman, and I'm wondering about that distinction you made between lexical and semantic. How does that relate to topic modeling?
So I'm not familiar with BERT topic. I'm familiar with someone with the BERT models is a transformer, so they're like a cousin to the LLMs. They're both transformers. They just use the encoder side or the decoder side. But I don't know exactly what are you doing with the topic modeling? Maybe I could.
Looking at large and small literary corpora. It's for literary.
Is the model itself like look at text and it says here's the topic that's
Right, exactly. Here are topics, and then that are like, well, they're called latent semantic spaces. So,
Okay.
but I don't know
Sure.
if that is like a literal use of semantic in the way you're talking about it, or if it's more of the literary use of the term semantic.
No, it would be related. It's been a while since I've touched on LSA type stuff. These days, everyone's kind of moving towards like doing it somehow with transformers. With like a BERT transformer, then I think you can train it to replace like with BERT. In this talk, we're using the model to build the encodings for the embedding vectors for the vector search. But you can replace the vector head with something that's just like, I'll train it to identify the set of the 10 topics that I would choose to do. So that's kind of an old school way of doing it. You can also use LLMs to kind of do the same things, and you can either put in the system prompt, here's the 10 topics, or you can just kind of like let it wax philosophical itself and say, here's the topics I pick up for it.
So just give it a more general prompt.
If you're going to deal with LLMs, yeah. I toss it in there and see. I don't know exactly your use case, but you can always ask an LLM, what's this topic? And probably give you a reasonable answer.
So I typically ask my LLM to return a JSON structure that I then will process, and typically I've been using kind of one of those fields that's been returned to trigger an API call or something kind of externally.
Mm-hmm.
So kind of before function calling was like a thing,
Mm-hmm.
and now I'm thinking, so should I kind of re-architect or think about these things? Are there efficiencies to be gained by direct function calling versus the way it's currently set up, where it's like JSON return triggers a function back to the LLM, repeat until completed?
I would definitely play with the function calling to see what it's like. Like OpenAI, for example, you can say put it in JSON mode and it'll return the JSON. It sounds like that's basically what you're doing. In some ways, internally, it's doing something pretty similar both ways. Maybe one benefit that you'll have in going the function route is these models have been really hardcore trained to understand the definition of the function, to understand the explanation of the parameters. So you might benefit in quality because it if it really matches that notion. If you just do what they do in training, you might actually benefit from going that route. But effectively, it's doing something similar. Also, if it's not broken, fix it. That too.
Oh, I didn't know what you meant by giving the large language model room to think.
Say it again?
Oh, giving the large language model room to think. Yeah, I don't know if you could expand on that.
Sure. That's a fun one too. Part of the longer talk was like the internals of the model, and so you get kind of an intuition of every time, it's not text in, text out, really. Text turns into tokens, and it's not even tokens out, it's one token at a time. So every time that you put in the 1, 2, buckle my shoe, and you put in that input, and it's going to figure out the next token. And there's no such notion of this token coming up with the last token there was really hard, or some other token, V is an easy token. There's no notion of that. It's the same exact calculation for everything. And every time that you create, there's an attention mechanism where every time you create a token, every word effectively can attend to the words that preceded it, and can attend to, like, basically there's a buildup of the abstract ideas that are built up before you see it. So by giving these models they're not really thinking, but by giving these models the chance to make more words that are statistically relevant to the problem at hand, and you prime it with let's think step by step. So it's going to create more words that builds up these more abstract ideas that are still shoved back in there in the prompt that is built out. Effectively, when it's finally time to make the answer, it can attend not only to the question, but it can attend to apparently what is a sense of reasoning. And so at this point in time, right at the end, its problem is a lot simpler. It just has to look back and pick out the answer from this jibber jabber that you let it do in its thinking. But the weird thing is, it's what we do too. It's like, especially it's what I do. If you guys know me, I externalize cognition. So a lot of times when I'm answering a question, I'm figuring out what the answer is by speaking.
But just to follow up on that, everything you just described is essentially a prompt engineering technique. You're just saying shape the prompt in a way that it prompts the model to have a longer response that includes a chain of the thought, rather than just asking for the answer directly.
Yeah.
There's no other knob you can twist.
There's not like a smarter knob you
Right,
can
you're
turn.
just giving it a different prompt, and it's how you're shaping the response from the prompt.
Does that mean then on like Claude, when it says thinking mode, is that just doing that on your behalf as the user? Or is that a separate?
Yeah, so a lot, the interesting story is what we used to call prompt engineering. All the good ideas from that have kind of been baked into the model over time, a lot. It doesn't mean that they're all that you should ignore what is happening there, because you can still use few shot examples and really help the model out. But chain of thought reasoning, thinking about the problem, especially the one I glazed over where like you say you map out the set of possibilities and navigate to dead end and back up and do something like that. That actually became one of the inspirations for this new thinking mode, the reasoning. And so if you actually look at like DeepSeek R1 reasoning, it's kind of got this emergent quality. The old chain of thought thinking, you'd say, let's think step by step, and it will run itself, paint itself into the corner, and then just walk through the paint and be like, I got the answer, and it's a lie. The newer versions of the thinking mode, it's somewhat emergent behavior, somewhat trained in the model, where it's found that it's a good pattern to go, and it realizes when it's like, man, I'm saying a lot of stuff, but I'm lying to myself right now. You need to back up and start a new tab. So that's why. So chain of thought is still useful, but a lot of times soon it's going to be completely baked in the model. You say, here's my question. It's very interesting. Thank you guys a lot. That was a lot of fun.